All right, time for another draftphysics.com, debatephysics.com. Also, video presentation. Yes, Ian Gosling. I knew I shouldn't have bothered watching the videos because he's just going to create another piece of fake evidence to make his argument, just constantly forcing somebody to point out obvious truths about reality, and it's just a waste of time, frankly. Um, and it's clear that making any points about how the physical universe actually works is pointless. Okay, these people are belligerently retarded. They can't, understand simple, basic arguments. So even the thin ice argument, they're mocking it, right? In the comment sections, they're mocking the idea that the thin ice argument's pretty persuasive in the sense that there's no other way to explain why you can go across thin ice without breaking it than to point out that the faster you go, the less pressure you're putting on the ice. It's the only explanation, okay? There's no other possible explanation. So it's clearly not linear pressure. It's clearly less pressure per square or linear foot. And, it's beneath having to argue. I mean, that's just flat earth stupid, somebody telling me that you can't go faster across thin ice and it won't work. You'll still fall through. That's what their physics says, and it's just too stupid. All right, so I have explained previously many times, I've pointed out the word joule. Okay, so the guy is famous for this very problem. Okay, you're going to create something that has energy. And you're really just saying, how do I measure how much energy it has? All right, and it gets complicated. I mean, everybody wishes it was really simple. So Joule would have loved it. All he had to do was spin a wheel and shove a sponge next to it. Take a sponge and crinkle it up so it has constant pressure against the wheel or the axle. It doesn't matter which. And then I can tell exactly how much energy it has based on how many times it spins. So Joule, okay, spent a big ton of money to make these very fancy insulated barrels full of water, made a little thing to go inside to swish the water, all this complex stuff. He actually invented, much better thermometers just for this purpose because he needed such precision to measure all. So, I mean, why would he have gone to all that trouble if all he had to do was spin a wheel? And put a sponge next to it and then count how many times it spins. Yeah, obviously he knew back in 1850 that isn't going to work, okay? That's not going to give him the answer he needs. His money was riding on it. He was going to decide between using, electric machinery versus steam machinery, and he wanted to know which one was more efficient. He wanted a real answer, and because he had a business to run, so his livelihood was dependent on him making the right choice, and so he didn't fall for this answer. Okay, he knew this ain't gonna work. All right, so as I explained previously, this whole argument is about the fact that if the pressure is being applied over units of time, okay, that means that if you're going very fast, there's three, they say it's 3 pressures per second, okay? And the fact is, when you're going slow, you're going to get hit with the 3 pressures in 1 second. That's what you're going to get hit by because it's 3 pressures per second. And if this whole thing here takes you 1 second to travel this whole distance, you're still only going to get 3 pressures per that whole distance. And this seems to be the argument above their competency. They can't understand that it's less pressure per unit of distance. So per unit of spin, it's less pressure. This is only producing a certain amount of force in a certain amount of time. It's a spring, essentially, and it's pushing with a certain amount of pressure per millisecond, per billionth of a second. It's a certain amount of pounds, okay, of pressure it produces in an amount of time. So this is essentially the same as gravity. It's doing the same thing gravity does. It has a constant pressure it's applying, and it doesn't matter how fast something's going, it's not going to change how much pressure it applies. So if it's going faster, it's obviously applying less pressure per square foot or inch of surface. So it's just like gravity in the sense that it's going to give you these non-linear results, because it's less friction the faster it's going. The faster it's going, the less amount of friction it's applying per unit of distance of surface. Fact. All right, so they just can't understand that. So I tried to explain that you have to use some mechanism that isn't a constant force in a constant amount of time. You have to use some mechanism that gives you a full unit of energy, and it's 1 unit. Okay, now if you hit something, the downside is if you hit, let's say you hit a ball bearing. You have a little thing and it hits the ball bearing. Well, the problem is it's going to hit it hard when it's going fast. It's going to give it a lot of velocity. So each hit will be a lot of energy. And the slower it's going, the less energy it's going to take per hit. It's just going to move it a little bit and that's it. A lot less energy to after it hits it. So that won't work. You could use magnets. But the problem there is the faster you go, you can defeat the magnet, right? Because the magnet's a constant force at a constant amount of time. So again, it's time dependent. And the fact is if you push 2 magnets together really quickly, they go together really easy. It's just a fact. Because you kind of defeat their capacity to defeat your effort, okay? Because you've taken the time out of the force. So the faster you go, the less force you have to overcome. Now you could do the opposite thing and create a magnet and a piece of copper. I don't know which way it would. All right, and try to use braking, okay, magnetic braking. But the problem there is that the faster you're going, the more energy you're pulling out again. So it's the faster you go, the more force it applies against you. And the slower you go, the less force. So it's not even either. It's not going to give you 1 unit of energy per impact. Now, I suggested a playing card or a piece of plastic, and you're just going to bend it, okay? And then it's going to flip back, and then it's going to get bent again. It's going to flip back. And I can't, off the top of my head, think of too much wrong with that other than the fact that, over time it's going to get weak because you're going to heat it. So it has to be something that bends fairly easy and restores its original state fairly quickly. So you could probably use a spring. Okay, so you could take a coiled spring and have it, have a little something that sticks out here, a little pedestal, and then you can have it hit the spring. All right, and bend the spring into this other position, and then it rolls off, and then it goes back, and then you hit it again. But, depending on the spring, it's going to keep wobbling, But it's probably better then. So it's better than a lot of other ways of doing it. But you really need something that's the same energy every time. That doesn't matter how fast you bend a spring, theoretically. You bend it quick, you bend it slow, it's the same work. The same amount of energy needs to be used to compress the little pieces of steel and all that stuff. So there's no advantage to speed, and there's no disadvantages. So it's always the same amount of work, and that's what you're looking for. And again, that's what Joule was looking for, and he couldn't come up with a simple answer. That's why he did this really complicated thing. Now, I'm arguing that maybe there is a simpler way to do it. This ain't going to work, okay? Applying a compression force won't work, because the compression force is just like applying gravitational weight. It's a constant force. A constant force won't work. So you need something that's in chunks of energy that you're going to say, I want to take the momentum from the object, and you have to take the momentum in known chunks, in 5-cent pieces or in $1 pieces. You want to take it in pieces that are all the same size, and then you can count how many pieces of energy you took out of the object, how many units of energy, okay, that are not dependent on speed. So you just need something that absorbs energy the same no matter how fast you affect it. And again, like I said, springs are sort of like that. I mean, they do have their limitations, but within a range, what they'll do is they'll show you how much energy, how much pressure something applies, and they don't care about time. They just care about the total amount of energy something can apply, how many foot-pounds, so to speak. They're good at measuring momentum. Anyway, so instead of having a rational, conversation about all this first and saying, well, this is what I'm going to try, or this is what I like. So let's understand the context here. 30 days ago, he did this very same experiment with a different friction source. Now, he didn't show it to us, but he said something about some kind of brush, okay, that he had against the disc. And when he did it that way, he didn't get his 4 times the rotation crap. It didn't work. Made a video saying it didn't work. What's wrong, guys? So, the whole spiel. So obviously you can contrive the mechanism to come up with any results you want. Like I said, I could use the braking, magnetic braking, and I'm going to get the opposite kind of results because I'm going to punish the fast motion. The fast motion is going to get highly punished. And the slow motion is going to get rewarded. Okay, it's going to lose less energy moving slowly than it's going to lose when it's going fast. And so you'll get the exact opposite result. You'll get some idea that it'll run out of, the fast thing will run out of energy so much quicker. And so you can engineer this experiment to produce any kind of result by just changing the friction, the mechanism of the friction. And that should be understood, and that reasonable people should recognize that if it was really easy, Joule would have done it this really easy way. He wouldn't have gone to all this trouble. And the fact is if you're going to claim you're going to do it some easy way, then you at least should have the willingness to explain how you understand that you are taking the energy away in countable units, in clear, understandable pieces. 25 cents. Okay, each time this thing goes by, it's 25 cents. You have to make sure it's the same amount of energy being taken from the object, no matter what speed it's going. Every rotation pulls exactly the same amount of energy. And this compressed sponge idea doesn't do that. All right. So is there anything else to say? So again, I've said before, there's just no point in communicating with these people. These people are not trying to honestly investigate the truth. They're just trying to contrive the show experiment, some kind of faked experiment, like the Chardonnay and the denting clay. Let's just dent clay. Okay, let's not penetrate clay. No, let's just dent it. Okay. Because I can create an outcome when you dent it that's very different than the outcome if you force the object to penetrate the clay. Because it cheats. And that's the simple truth. This experiment cheats your eyes in the sense that this sponge, okay, is not applying the same amount of friction no matter what speed you're moving it at. It's less friction per linear inch, okay, and it's completely dependent on how fast it's going. The faster it's going, the less friction per linear inch. The slower it's going, the more per linear inch. So it's not extracting the energy evenly. All right. It's not in 25-cent coins. It's 5 cents in the beginning, and then it's 50 cents at the end. It's not proportional, and it's not even. All right. And so just to reiterate, I'll read a couple of comments, I guess. It's just, like I said, they're just shameless in their denial of the truth. All right, so just to be clear, all of this is based on understanding what gravity is, okay? And the fact is that it comes in units of time. You get 9.8 meters per second of velocity every 1 second. We know that's the fact. All right, and so again, I make this simple argument about thin ice, and that you can have ice that's thin, and it will break. So if I put 10 pounds on top of the ice and just let it sit there, it falls through the ice. But if I slide the 10 pounds across the ice at a velocity, it might still fall in. But there's a certain speed I get to where I'm now applying the force of gravity. I'm making it thinner and thinner, okay, because of the fact that I'm moving the object across the surface faster and faster. So the amount of pressure at any one point goes way down the faster I move it. So the faster I move the 10 pounds, the less weight, right? If the weight sitting there, you could understand, is the full force, the full 1 second of 9.8. But if I can cut that second in half, that is, there's only on here for 1/2 a second, you can understand right away that, oh, okay, well, it's at least half as much weight, okay? And then if I made it a quarter of the time, well, that's 1/4 of the weight that's on this piece of ice. So obvious, it's just so obvious. And to have to argue that that's the reality. The reality is the weight is applying less pressure to the ice, means it's giving away less of its energy. As it slides across the ice, it's giving away less of its energy because it's not stuck to the surface. So the faster it can go, the less it will give to the surface per foot, and less actual amount per foot. And the slower it goes, the heavier it gets per foot. I mean, it's just so obvious. Starts off with this little arrow, at a high speed, and by the time it's stopping, it's applying its full mass to the surface. Here it's barely applying any mass at all to the surface. Here it's applying its full mass to the surface. And there's no counter argument to that fact. The friction isn't linear, and it is, in fact, completely time dependent. Gravity is a time dependent force. How long you're in it decides how much you can collect from it, and you have to be free falling. Yeah. If you're not free falling, then the in it part doesn't matter. All right. Just too stupid. I mean, I guess I shouldn't say, you're free falling when you're on the ground. I'm just saying that the amount of pressure you're putting on the ground is completely dependent on how long you're on that piece of the ground. And the shorter the amount of time you spend on that piece of ground, the less force you can possibly impose on it. You can't weigh something on the surface if you're not sitting on it, if you're not on it. All right. I just don't know how else to... it's just, like I said, the thin ice argument is just so obvious. Clearly, you can defeat thin ice by traveling quickly. And clearly, the reason why you can defeat the thin ice is because you're going to lose less energy to the ice. You're going to be imposing less weight on it. Fact. You'll be making less contact with it. All right. All right, we'll call it a video. But there's really no point, right? He's just done this over and over and over and over. He just keeps contriving experiments to force the outcome to be consistent with what he wants to believe. And it's all such bad science. It's bad physics. It's bad logic. And he just doesn't care. Fact.